Hi and welcome to my channel. In this video, I am going to discuss about the topic solid state. Most of the things we see around are solids. Solid state is one of the physical state of matter. Matter is nothing but substance that occupies space and has mass. We know that each and every substances are made up of atoms, ions or molecules, that is called as constituent particles. So matter exists in three different forms, mainly three different forms: solid, liquid and gas. Example, water. Water can exist in three forms, so ice, water and water vapor. Ice is in the solid state, water is in the liquid state and water vapor is in the gaseous state. So H2O exists in three states. So now, at a particular temperature and pressure, okay, the water, the most stable state of water can be determined by two opposing forces. One is intermolecular force and the other one is thermal energy. These two are opposing forces. Intermolecular force tends to keep the constituent particles closer. That is, it will keep the constituent particles very close, that is tightly packed. The attraction between the constituent particles will be greater. For example, if you take the NaCl crystal, in this crystal the constituent particles are ions, Na plus Cl minus ion. There is a force between this Na plus ion and Cl minus ion that makes the particles very close to each other. So now in this crystal, ion is a constituent particle. In diamond, atom is a constituent particle. Carbon atom is present here. In graphite, carbon atom is present here. Okay, carbon atom. This is atom is a constituent particle in diamond and graphite. Okay, so here intermolecular force tends to keep the molecules closer, and thermal energy keeps the constituent particles apart and make them move faster. That is the thermal energy. So here, when the temperature increases, when we increase the temperature of ice, thermal energy increases. So when the temperature increases, ice gets converted into water. That means the force between the constituent particles get reduced due to temperature. So intermolecular force nothing but the chemical bond. Maybe an ionic bond in a crystal or a covalent bond or metallic bond, like that. Okay. So when we increase the temperature, the intermolecular force is reduced there, and this temperature makes the constituent particles move apart. So now ice gets converted into water, and in this water the constituent particles are loosely packed. Again, if we increase the temperature of water, the thermal energy increased again, and here the water gets converted into water vapor. Here the constituent particles are moved apart. The distance between the two constituent particles will be greater here. Very loosely packed in gaseous molecule. Okay. So ice to water, it's melting, and water to water vapor, it is vaporization. So again, if the temperature increases, it moves from solid to liquid, liquid to gas. When the intermolecular force increases, that means if the water vapor is cooled, okay, when the water vapor undergoes condensation, it will give water. In this time, the intermolecular force will be greater now. So when the temperature is reduced, the force acting between the constituent particles will be greater. So the constituent particles come close to each other. So the intermolecular force will be greater here, and water vapor gets converted into water. And again, water gets converted into ice by increasing the intermolecular force. Okay. So at very low temperature, this water exists in the solid state. Any matter at very low temperature, it exists in the solid state. At low temperature, the pressure will be higher. So pressure, if you change the pressure, high pressure and low temperature, at a condition at low temperature and high pressure, if pressure increases, constant particles is lesser, so the forces acting between the constant particles will be more when the pressure is high. And the temperature is low. Temperature is low and pressure is high means intermolecular force will be greater. If the temperature is high and pressure is less, thermal energy will be greater. So thermal energy, it will make the constant particles move apart, and intermolecular force tends to keep the molecules closer. Okay, so this is at very low temperature. This water is in the solid state. The intermolecular force between the constant particles are greater here, and they are in a fixed position. These constant particles are in a fixed position. Okay, so now in this chapter we are going to discuss only about the solid state. Solids have constant particles. Solids are regularly have constant particles, that is atoms, ions or molecules, and in solids the constant particles are arranged in a regular manner. Suppose we'll take an example, NaCl crystal. The constant particles are sodium plus ion and Cl minus ion, that is chloride ion. See here, these constant particles are arranged in a regular pattern. So Na plus Cl minus, like this, the arrangement is in a regular pattern, orderly arrangement of an constant particles in this crystal. And here the constant particles are ions, so it's an ionic crystal. Okay, and in this here the constant particles, in between the constant particles, there is a force acting between these force acting. Okay, that force is called as intermolecular force. Okay, and these forces keeps the molecules together, keeps the constant particles together, and the constant particles are fixed or in fixed position. Constant particles are in a fixed positions. Okay, so now the properties of the solid. The properties of the solid not only depend upon the nature of the constant particles. It is an ionic solid, so it has an ionic bond. It has the character of ionic properties of the ionic crystal. Okay, right? This is Na plus and Cl minus ion. The constant particles are ions. Okay. Here, the constant particle, that is the particle which is present in diamond, is carbon atom. Okay. Their properties are different. And graphite, their properties are different. Okay, clear? So, in a crystal, in a solid, the properties of the solid, the properties does not depend upon only the nature of constant particles. It also depends upon the arrangement of the constant particles as well as the type of forces acting between the constant particles. So properties first, nature of the constant particles. So here ion, here atom, and in some solids we have a molecule as a particle. Okay, so the nature of the constant particles are different here. Next, arrangement of the constant particles. The properties also determined by the arrangement of the constant particle. See here, this is an arrangement of NaCl crystal, and it's a cubic. We'll learn later in this chapter. See here, this is diamond. Diamond, each carbon atom, actually it is tetrahedrally arranged. So each carbon atom is shared by 4 other carbon atoms. A covalent bond is present here. It is a covalent solid. See here, in this diamond, there is tetrahedral arrangement. This is graphite. Both consist of the same carbon atom, but here the arrangement is hexagonal rings, hexagonal structure. Okay, layers, different layers of hexagonal rings are present in graphite. So the arrangement is different for these two. Both has the constant particle atom, carbon atom. Okay, and this diamond is very hard. The properties of diamond, they vary. So based on the arrangement, the properties may vary. It is very hard. Diamond is very hard and graphite is soft. Okay, and next one, the conductor. It is an insulator. It's a bad conductor of electricity, whereas the graphite conduct electricity. Okay, conductors. Graphite is a good conductor. Diamond is a bad conductor. Okay, these are the properties. See, This property difference is due to the arrangement of the constituent particles. Okay, it's not on the nature of constituent particle, it is depend on the arrangement of the constituent particle. Okay, next point, the properties also depends upon the type of forces that acting between the constituent particle. So here it is the constituent particles are ion in NaCl crystal. So Na plus and Cl minus, an ion electrostatic force of attraction will be there between Na plus and Cl minus ion. So ionic bond is there. So the character when it is, we know that in the ions, ionic solids, if you dissolve it in water, okay, it gets converted into ions, so it will conduct electricity. But in the solid state, it acts as an insulator. Like that, the covalent bond, the property is different between the NaCl crystal and the diamond. Okay, so that is based on the arrangement of the constituent particles. The properties vary, and the next one, the type of forces acting between the constituent particles. The properties of the solids vary for different crystals. Okay. Now we will see about the general characteristics of solids. Solids have definite mass, volume, and shape. So it has a definite mass. They are regularly arranged. Okay. Definite volume and has a definite shape. Next point is short intermolecular distance, and next point also, that is strong intermolecular force. When the intermolecular distance is very short, okay, if the distance is short, the intermolecular forces will be very strong because the constituent particles very closer, so the force of attraction will be greater there. Okay, so the distance is short means when the distance is short, the force of attraction is greater, strong intermolecular force. Next, most of the solids are incompressible and rigid. So we know that solids are rigid, hard, so it is not compressible. Okay. The next point, the constituent particles are in fixed position. See, it is in fixed position, I told you before. The constituent particles have strong force of attraction, so they are tightly packed. So all the constituent particles in a crystal are in a fixed position. Okay, and can only oscillate about their mean position. If it is oscillate, it will oscillate only in their mean position. Okay, like this it will oscillate only in the mean position. Okay, so now this is the general characteristics of solids. In the next video, I will explain about the classification of solids. Thank you.